Here's a video that's going to go through the very end of Chapter 6, which focus was really analyzing a polynomial function using the calculator to help us determine different values of the function, different points on the graph, specifically the turning points, the maximums and minimums, any zeros that are on the graph, and then also using the idea of end behavior to describe the graph that we see. So I'm just going to do one problem, but it's going to take you through a little bit of everything, and we're going to go through the calculator sequence so you're comfortable with those buttons. You get a chance to practice it before you take your test. So the problem wants you to analyze the polynomial function. It does tell you to use a calculator, so that's how you know to go to the calculator and look at it. I'm going to fill in a table. I'm going to look for maximums and minimum zeros, and then finally write the end behavior with the correct notation. So first, let's look at it on the calculator. The first step for any of these problems is we need to graph it. So when you go to your calculator, you're going to go to y equals, and I want you to type in exactly what you see for the function. Make sure you type it accurately. If you have one sign off or one number off, you're going to be looking at a very different picture and have very different answers. So that's the first thing you want to check. Make sure you graphed it correctly. Second thing you want to check is we want to start with a basic 10 by 10 window and see if we can see everything that should be happening. So hit zoom 6 and that will take you to your basic 10 by 10 window. Just in case the last problem you did, maybe you had changed your window slightly, especially with some of the word problems earlier in the chapter. So here's a picture of our graph. First thing that we can see visually is that it crosses the x-axis 3 times. That means it has 3 zeros. They are all real. This was a third-degree polynomial, so I had all 3 real, meaning there are no imaginary zeros. The other thing that I can see are the turning points. This graph has 1 minimum and 1 maximum, so I'm going to have to find the coordinates of those. And we can also talk end behavior a little bit, the idea that on the left side of the graph it's going up, and on the right side of the graph it's going down. We'll write that correctly in a second. Let's start by filling in the table, and a lot of times you can do these by hand, but the calculator creates an entire table for you, so it's very easy to use theirs rather than filling in your own. If you go to the table function on your graph, which is second and then graph, you actually get a table, and your table should be set up to only go like one at a time. Now I want to go back to -3, so I'm going to hit my up arrow a couple times. And now I can see everything in my table that I want to fill in. I can see that -3 goes with 103, -2 goes with 36. So I'm going to start filling this in. Not necessarily that I'm going to graph all those points in my graph, but it gives you an idea of what's happening. -1 goes with 5, 0 goes with -2, 1 goes with 3, and 2 goes with 8. 1 goes with 3, and 2 goes with 8. So it gives you a series of points. Obviously, we're not graphing the point -3, 103 on my graph, but the idea that on the left side it's getting really big. If you kept going more in the negative direction, your f of x values, your y values would get larger and larger. So that's the first thing you should be able to do with your calculator, so you're not plugging them each in by hand one by one. Second thing we're going to do is we're going to identify those maximum and minimum points. So we're going to go back to my graph, hit graph so you can see it. I'm going to go to the Calculate menu, which is second, and Trace. It wants maximum first, so maximum is number 4, or you could just use your arrow to go down to it. Now it's going to ask you can see where the cursor is flashing, to left bound. Essentially what you're doing is you're marking around the maximum. So I'm going to go a little bit to the right, just kind of follow the curve a little bit. Any point in time I can hit enter, because I want to hit enter before I hit to my maximum. And it puts a little mark there. And then I'm going to go along the curve until I go past the maximum. So anytime now I'm past the maximum, hit enter. It's going to ask guess. Hit enter one more time. Make sure you hit enter enough until you see the word maximum on the bottom of your screen. You should also see the cursor flashing at the maximum. What I need to write is the full coordinate. I'm going to write 3 decimal places for each, and I want to make sure I don't just write x or y, I write both. Your maximum is the entire point. So I have 2.8080 as my x coordinate, and my y coordinate 8.040 or 041. You can round or truncate. That is my maximum value. Then I'm going to do the exact same thing but use the minimum button. So I'm going to go back to that Calculate menu, which is second Trace, choose minimum this time. Now I need to use the left arrow and kind of get a little sooner in my graph. I need to go before the minimum, so anywhere on the left side of my minimum is good right there. Hit enter. Then I'm going to go right arrow to go past the minimum. Hit enter to guess. You always can tell if you've hit enter enough because the bottom of your screen should say the word minimum. So my minimum is at -0.080. And my y coordinate of my minimum, -2.040. Again, I have a full coordinate. I know exactly where that point is, so you need to get in the habit of writing both the x and the y. They are both very important to your answer. Now I'm going to come up with my zeros. So my zeros are the places that cross the x-axis. This is going to take a little longer because there are 3 of them, and you want to make sure you list all of them to get full credit. I go back to the exact same menu, second trace to the calculate menu, hit 0, number 2, or you can just scroll down to 2 and hit enter. I like to do them in order from left to right. So first I have to be the left side of the first 0, so before it crosses the axis, hit enter. Use your right arrow to go through the axis. Anytime you're through the axis, you can hit enter again, and then a third time to guess. Again, on the bottom of the screen, it will say the word 0, so that's how you know you're done hitting enter. My 0 here is at negative 0.600 or 0.601. It doesn't matter if you round or truncate. Negative 0.600 or 0.601, comma 0. Your y coordinate should be 0, because it's where it crosses the y-axis or the x-axis. Now I'm going to do it again for the next one. So go back to the calculate menu again. So I need to be before it crosses the axis, so this is fine. Hit enter. Then I need to get after it crosses the axis. I'm going to use my right arrow until it's gone through the axis. Hit enter, and one more time. There's my next 0. It is at the point 0.544. 0.5440. And finally, I have one more. Go back to that calculate menu one more time. Hit 0. Anytime now I can hit enter because I'm before the 0, and then I just have to kind of follow my cursor until I'm past it. Hit enter twice. And there's my last one. Now, one thing I do want you to notice how the calculator wrote this. The x value is 3.056 or 0.057. But notice what they wrote for the y coordinate. They didn't write 0. They wrote negative 1.5 e to the negative 12th. That's scientific notation. The calculator will do that sometime. That is 0, but they're writing it as if it's, if you think about moving the decimal place over 12 places, as if it's like 0.0000000, and then the 1.5, and so on. That is 0. Do not write negative 1.5 times 10 to the negative 12th. Don't write negative 1.5. It is just 0. And you can see visually that it's on the axis, that it has a y value of 0. When you go to draw a picture, I don't need it to have all of these points. Obviously, if you look at your table, you're not going to have the point 103, but it should have the general shape about it. So I am going to put some points here for my zeros. I know I have a 0 at negative 0.6, so right around here. I know I have a 0 a little over a half, and I know I have a 0 a little over 3. I know that my maximum is going to be a little bit off of my table just because I made it bigger. It's going to be up here somewhere. And my minimum is going to be negative 8, negative 2. It's going to be around there. And I just want to get a general shape of my graph. So you can see that it kind of goes down through. Oh, I have it a little off. I'm going to move it a little bit. Move this point a little bit. This point is a little closer to 0. Should be about there. So I'm going to try to connect the dots and get something that's a general shape. It does not have to be perfect, but it should have the same general shape and behavior and points that you see. So you're getting something that looks something like this. It's coming down, coming up through there, all the way up there, and then back down. Now, when it comes to end behavior, it is important that you know how to write end behavior. The nice thing is that when you look at your test, you will see correct notation of end behavior on it, so you do not need to memorize it. You just need to be able to model the same thing that's written on your test. So here's what end behavior is. As x goes to infinity, this means what is happening as I go to the right side of the graph. My function, that's my y value. As I go to the right side of my graph, notice my graph is getting smaller and smaller and smaller. So that is going to negative infinity. It's going down further and further and further. As I look on the left side of my graph, that is as x goes to negative infinity. That's what's happening over here, this end. This end is getting higher and higher and higher, going up and up and up. So my function, or my y value, is going to positive infinity. So you should be able to look on your test at one single function and be able to answer all of these questions. You complete a table to get different y values. Find minimums. There can be more than one. Find maximums. There can be more than one. Find zeros. There usually is more than one. There are a few that only have one, but a lot of our functions, especially with higher degree, have multiple zeros. And then also complete the end behavior. And your calculator helps you with so much of this. It gives you the picture. It gives you the table. It gives you the specific values down to the decimal point, and it also helps you with the visual for end behavior. So this is a full calculator calculator problem, you will see an entire problem like this on your test. It is worth a lot of points because you're asked to do a lot of tasks. So if you know how to do this, this should really help your test scores.